Okay, so this section is on LS, which we've already talked about. We've already gone over. We're going to go into a little bit more detail on LS, and in particular, permissions. That's really the focus of this video, is permissions. In order to look at permissions, first we need to have something a little bit more interesting to look at than anything that we've used so far. So I'm going to start by clicking on Applications, going to Accessories, and coming down here to gvim. Vim is something we're going to become very familiar with later on. Vim is an editor that we run inside the shell. Gvim is graphical Vim. So it gives us some nice things to make it a little bit more intuitive for you at this point. So when you type in gvim, you get this nice text editor layout, and it tells you VI improved, the version, and all that fun stuff. The first thing you need to do is hit the letter I. And you notice at the bottom left-hand corner, it says insert. That means that we can now type things in. And I'm going to type in echo, and then quotation mark, hello world, and then closing quotation mark, right? Very common thing in programming. Your first program is always hello world. Then I'm going to click on the save icon here, and it's going to ask me where I want to save it, and I got to give it a name. So I'm going to call it hw.sh. Remember, in Linux, file extension means nothing. This means this is a bash shell, right? So we want the computer to interpret it as a bash shell. What does that mean? That means that every line inside this piece of text will be interpreted as if you had typed it in at the command prompt. Let me go ahead and hit save, and then I'm going to close that. Now I'm going to open up the terminal, and if I type ls, I see hw.sh. If I type in ls-l, we see that for hw.sh, if you remember from our lesson before, we have our three groupings of permissions: read, write, and execute for the user. That's the first grouping right here, right? Then the next grouping is for the group that this belongs to, and the final grouping is for everybody else. So the user, the owner, which is root, me, has read and write permissions. The rest of the world, or excuse me, the group, which is the root group, has read permissions, and then the rest of the world has read permissions. Just to let you know what does that command do, let's type in the command echo hello world, and it just prints out hello world. Echo is a very common command if you just want to print text to the screen. We're going to use that a million times over during this course. So we told you that we gave it the .sh designation so that the shell would interpret it as a bash shell and try to interpret each command as a command. I can force it to do that by typing in bash hw.sh, and we see it prints out hello world. It executes that line, echo hello world, for us. I can also just type in hw.sh, and then it tells me, oh, permission not found. Or very commonly, you'll get permission denied. Because I'm root, it'll never tell me that permission was denied. But if you're logged in as a regular user, it will say that a lot. What it means is it doesn't think I have permission to execute this. Remember, I have read permissions and I have write permissions, but I do not have that X. I do not have execute permissions. So how do I get those execute permissions? Well, I use chmod, and I'll change mode, and I will say all plus execute hw.sh. And now when I type in ls-l, you will see that I, as the owner, have execute permissions, the group has execute permissions, and the rest of the world also has execute permissions. You will also notice that the color changed, right? It was white before, and now it's green. That's to indicate that I'm able to execute this shell script. Not all Linux terminals have the ability to show color, but this one does, so we see that. Now when I type in hw.sh, hw.sh. And that's this is why I keep telling you to always be explicit about your relative path using the /. Some things work without doing that, other things do not, and Linux is fickle. So, okay, now we know how to add the execute permission. Let's talk a little bit more about what permissions mean. Let me do ls-l again. If you recall, the very first segment is a special, I can't highlight that, I don't know why. The very first bit, we call that a bit, and you'll see why in a second, is a special bit. If it's a D, it means it's a directory. If it is a link, and we probably won't go over links in this short course, but you know, this is how you create them with the ln. And then I'm going to call this one hwlink.sh. And now if I do ls-l, we see that I have a link here, and it shows me that it's a link by giving me a little arrow to show me what it points to. And then it has an L right here as that special bit. A link is basically a shortcut. So you know in Windows you right click on something, it has the option to create a shortcut. That's all a link is. It's just another name that refers to the actual same file. When you get really into Linux files, that becomes important. It isn't for us. That special bit can also be an S, which is a sticky bit, which gets in special things with directories and executability, and we don't care at this point. So the special bit will either be a directory or a link or nothing, just a regular file. Then we have our read, write, and execute for the owner, the group, and then everybody else, right? Actually, we should say the user, the group, and then everybody else. We can change permissions by doing chmod. And in this one, I'm going to say the user, I'm going to subtract write permissions from hw.sh. And now when we do ls-l, and I'll just show you hw.sh, we see that the user no longer has write permissions, right? That's called symbolic subtraction. Before, what I was doing was symbolic addition. I can also do chmod all minus execute hw.sh, and now when I do ls-l hw.sh, we see nobody has execute. So A is for all, U is for user, G is for group, O is for other, everybody else. And that's as complicated as it gets for symbolic addition and subtraction of privileges. So I can add, read, write, and execute to anybody, or I can subtract it. Now, you will often see something like this. Chmod 775 hw.sh, and then when we look at the permissions, how did that happen? How did the permissions change like that? That has to do with the way that Linux interprets numbers. So let me go, let's talk binary, right? This is not a class on binary. I'm going to give you some links to some binary resources. Binary is an incredibly useful thing to know. You should know it, but you don't need to for the purposes of what we're doing, except for a few special cases like this. So I'm going to start right here. Just going to start in the middle, and I'm going to say, what if I have a binary number 1, 1, 1, right? What that means is this is our 1's place, our 2's place, and our 4's place. 1, 2, 4. Just like, you know, in base 10, which is what you're used to, you have the ones place, the tens place, the hundreds place, right? So 111 in base 10 would be 1 plus 10 plus 100. Right here in binary, it is 1 plus 2 plus 4. 1 plus 2 plus 4 is 7, right? And I'm going to go down here and say, and again, let's do our 4, our 2, our 1. And let's say that it is 0, 1, 1. This means no ones plus 2 plus 4, and we get 6 in decimal. And then down here we could write that as, we could write the next one, 4, 2, 4, 2, 1, and let's say there's a 1 there, there's a 0 there, there's a 1 there. This means 1 plus 4, which is 5. All right? What the hell does that mean, and what does that have to do with what we just said? Well, if you look, I did Chmod 7, I think this is just in view. Chmod 775. So for the first group, which is the user, I said 7, which is read, write, and execute, all turned on. Those are all ones. For the group, I put a 7. So that means read, write, and execute are all turned on right here. And then finally, for everybody else, I put a 5. A 5 is read is turned on, write is turned off, execute is turned on. So everybody else, they cannot change the file, they can't delete the file, but they can read it and they can execute it. And by the way, you always want to be able to read and execute at the same time. There's no reason not to. So sometimes you will see Chmod show up like this. It will show up as the numbers instead of the symbolic, you know, user, group, other, or all. Okay? Yeah, so that is the gist of permissions under Linux, right? We can view the permissions using ls-l, right? We can change the permissions using chmod, change mode, and in order for us to execute any scripts or binaries or anything like that, it has to have the execute permission turned on for however, you know, whatever we are, whether we're group, whether we're user, whether we are everybody else. And by the way, Linux always interprets you as in order from left to right. So first it tries to check, are you the user? If you're not the user, then it checks, do you belong to the group? If you don't belong to the group, then you fall into the other category, everybody else. Yeah, so that is permissions in a nutshell. Hope that made sense. Hope that built on everything that we've done before, and this is going to come up again in the future. All right? If you have any questions, shoot me an email.